Okay, the strategy is listed up there again. Get a zero on one side, factor the other side. If factoring is successful, apply the zero product property. So let's try this to x squared equals 144. Well, we need a zero on one side. Okay, so subtract 144 on both sides. X squared minus 144 equals 0. Does the left side factor? It sure does. It's a difference of squares. So x plus 12 times x minus 12 equals 0. Apply the zero product property, right? And we have x plus 12 equals 0 or x minus 12 equals 0. Now, a little bit of work on each equation. So x equals negative 12 or x equals positive 12. Folks, it is helpful to know this zero product property by name because the name is very helpful. A zero on one side, product on the other. So zero product property. Let's solve x squared minus 49 equals 0. There's already a 0 on one side. We just need to create um, a product on the other side, which was created by factoring. So we'll just start factoring already because one side already has a 0 on it. Okay, so x minus 7 times x plus 7 equals 0. So zero product property applies. There, we have x minus 7 equals 0 or x plus 7 equals 0. Instead of one big equation, we have two smaller equations. And then we end with x equals 7 or x equals negative 7. Actually, there's another strategy we should mention. So for both of these equations, right, x squared equals 144, as well as x squared minus 49 equals 0. These are both examples of quadratic equations with no linear term. And so we're going to introduce another strategy. To solve a quadratic equation with no linear term, step 1, have the quadratic term on one side and the constant term on the other. And then square root both sides. Remember that when you square root both sides, you got to have a plus or minus sign on one side. So we already solved this x squared minus 49 equals 0. We previously solved it. Let's now try solving using the new strategy. So the new strategy, there's no linear term, right? There's no like 8x kind of thing here. There's no linear term. There's a quadratic term and a constant term. Let's get each on their own side. So let's add 49 to both sides. Okay, that's step 1. We add it on both sides. Now we have x squared equals 49. So the quadratic term is on the left side, the constant term is on the right side. Step 2, square root both sides. Don't forget your plus or minus sign. So instead of writing on top of the line here, sometimes people want to take this line that says x squared equals 49 and just draw radicals on top of each side as their own reminder that they're square rooting both sides. You don't need that. Just, you know that you're square rooting both sides. Just in the first line where square rooting occurs, you got to have that plus or minus sign. The left side's going to simplify to just good old x, right? So the root and the square root and the square power will undo each other. You're left with x. Copy the plus or minus sign, and root 49 will simplify to the 7. Okay, just keep in mind the other strategy had x equals 7 or x equals negative 7 as a final answer. So here's the thing. In x equals plus or minus 7, that symbol is read plus or minus. That is actually the language being used. So or appears, but it's hidden within the symbol, as opposed to or being written out in words. That's in part why it's so important that you need to write the word or. But there's other reasons that we won't dig into right now for writing the word or. Both strategies in the end produce the same two x values as solutions. Okay, you may skip writing the step that says root x squared equals plus or minus root 49, but you may not have a step that just on its own says root x squared equals root 49. That's missing the plus or minus sign. Okay, so the plus or minus sign must appear in the first line where you square root both sides. Leave the line that says x squared equals 49 alone. Write square root symbols on the next line down instead of trying to write on top of existing work. Okay, let's try this one. Let's solve u squared minus 11 equals 0. Here, the variable is u instead of x, but the same general principles should apply. Notice that there's no linear term. So I'd like to try the new strategy where we get the quadratic term on one side and the linear term on the other. So u squared equals 11. Now we square root both sides. Yeah. So notice that instead of drawing square roots on top of the first line of the answer, on a new line, there's radicals written as well as a plus or minus sign. That first step in which you square root both sides needs to have a plus or minus sign. On the left side, the square root and the square undo each other. You're left with u. On the right side, nothing simplifies. Right? So we just leave it as plus or minus root 11. Also accepted would be skipping the step, the middle step of the answer above, and just going from u squared equals 11 to directly to u equals plus or minus root 11. What is not going to earn full credit, you see in the red box, is writing down a line of work that says root u squared equals root 11 does not earn full credit. So why is a sample in red not earning full credit? It appears somebody took u squared equals 11 and just wrote a square root symbol on both sides on top of this without a plus or minus sign. But the first step in which square rooting occurs on both sides must have a plus or minus symbol, and all future steps as well. This is why it's best to just not write on top of existing work that's finished. If you've written an equation down and it's already equivalent to what was written, the step above, call that line done. Don't write on top of it. Start a new row of work instead. So why does this matter? If you gave root u squared equals root 11 to a mathematician, they'll only turn out for you here just u equals root 11. Note that u equals negative root 11, that solution would end up being missing in that process if you take it literally. And you really want it to be so that every single line of your work, right? So each line of your answer, it's like that moment you could pass that off to somebody else and they ought to just do the steps that would lead to the same final conclusion as you. Okay, so in your work for equations, each line of your work should in principle be a starting point for a math problem. That was what we were saying here, right? So if somebody were to pick up your work from the middle, they should end up in the same place. So for the last example, if a step had said root u squared equals plus or minus root 11, then people could correctly arrive to the final answer of u equals plus or minus root 11. But if in the last example, if a step had said root u squared equals root 11 with a plus or minus sign missing, then the left side simplifies to u, and the right side just remains root 11 alone without the plus or minus sign, because the expression root 11 doesn't automatically have a plus or minus sign attached to it. Remember that an expression should be one number. You got to go back and look at when we looked at radicals. We said that a radical just on its own isn't going to just automatically have a plus or minus sign. That plus or minus sign should appear in the first step in which you square root both sides of an equation. Okay, other notes. Notice that the previous question ended with u equals plus or minus root 11, and we couldn't simplify further. The question before, we had x equals plus or minus root 49, and that simplified further to x equals plus or minus 7, simply because root 49 simplified further. Yeah, that's the difference. 49 is a perfect square, while 11 is not.